Okay. So now we're going to talk about the data extraction and data conversions because they are very important while you're working on systematic review and meta-analysis. You need to know these skills to convert some values into another. For example, most of the time we use the mean and the standard deviation. And the mean and the standard deviation, you can find it in the article you're working on. You find the median and the interquartile range. So you need to convert median and interquartile range into mean and the standard deviation to put it in your chart, your data extraction chart, or usually it's called table 2. So first, I have some examples about conversion and so on to help you understand how we convert these values into another and so on. I brought 2 examples today to work on. So here, let us this paper I was working on. It is not published yet, the systematic review and meta-analysis we are working on, but it is it was asked from me to calculate the follow-up value. As you can see here, I will zoom for you. The follow-up period is not in the tables. It wasn't in the tables here. If you can see during follow-up, but there is no follow-up value in the tables. So it must be somewhere else. So I read the manuscript, the article, and I found the follow-up here. The follow-up here was in 2 groups. Was 50.9 plus or minus the standard deviation. I mean 29, and the other one, as you can see, 52.7 plus or minus 28.7. So I can put it in the flow chart. I want to give a follow-up period in mean and the standard deviation, but for the whole article. So how can I do that? And I have 2 values, so I need to combine these 2, mean and the standard deviation, into one. And this combined mean and the standard deviation, this is the one that I will use, and I will insert it in the data extraction spreadsheet that I am using in making the systematic review and meta-analysis. So how do we combine this? There is a tool. This tool, it's called combine mean standard deviation. Just write the first name like this, and you will find it on Google. As you can see, states to do combine mean and standard deviation. So how we do this? Let me remove this, please, and refresh to make you see how it looks. This is how it looks. So how we do this? You type the required data, which is the sample size, the mean value, and the standard deviation into columns. Like this, I will show you. This is a column for the sample size. This is for the mean, and this is for the standard deviation. Then you click combine data into a single group by decomposition mean and the standard deviation from all groups. This you will have the combined mean and the standard deviation that you can use in your systematic review and meta-analysis. So in our example here, I have two means and two standard deviations for two groups. This is the first group, and this is the second group. So what I need now, the sample size of each group to put it into the tool that I am using. So first I want to get the vitrectomized sample group, sample size of this group. It was this number, 11,785. So I will put here in the tool 11,785, then space. This is a column. This is a column for the sample size. The other column will be for the mean value. So let us return. What was the mean value here? The mean value here was 50 something. I don't know. You will take it as where it is. Yeah, here. You will take it as copy and paste. Here the 50.9. You'll put it here, paste it here, then click space. This is the other column for the mean value. So you need the standard deviation. The standard deviation was here 29. So you take copy and paste them, and then put them here. This is the last column for the standard deviation value. Then you will click enter to put the other group, the other mean value and the standard deviation. The other one for the non-vitrectomized groups, it was the sample size was 58,825. So you will put it here. 85,925. Let me check. Wait. So yeah, I wrote it correctly. Then we need the mean value. The mean value was 52.7. We'll take copy, paste them here, then space, then the standard deviation here, then paste. Then you will click combine data into a single group by decomposing mean and standard deviation from all groups. Here you have the combined and mean and standard deviation that you can use. So that's the first skill you need to know in data extraction, the combining of mean and standard deviation into one. So here it is. So now we have the other skill that you need to know, the conversion of median and interquartile range into mean and standard deviation. So there is another example here. Wait, I was working on this one. So if you want to the tables of the characteristics, the baseline table of this article, you'll find the follow-up period in the median and interquartile range. And these numbers are in days, actually. How I know it was in days, because they wrote it in the methods or the results. I don't remember. I think in the methods, but I don't remember where it is. But I remember while reading it, these numbers are 4 days. In days, I mean. So I have three groups here with three median and the interquartile range for follow-up period. So how I convert them into median and standard deviation. There is a let's say a tool. It was made into spreadsheets by Dr. Anas. I will put Dr. Anas' YouTube channel in the description, inshallah. He made this he made this spreadsheet for doing all this, the correlation coefficient calculation, the standard deviation change. We will discuss the standard deviation change also, and the standard error into standard deviation, the component interval to standard deviation, the median and the quartile range to mean and the standard deviation. This one that we will discuss now in the tab number 5 here. So what I will do, because the file is not mine, of course, the file is not mine. So basically, we will take this, copy paste, and make another file, another spreadsheet here, and we will paste the what Dr. Anas made, the sheet, the spreadsheet, and we will do like this. So there is some, of course, there are some guidelines Dr. Anas put. Just they are for to make not to manipulate the calculation he made in the spreadsheet. So I just want you to make sure that you do not manipulate these calculations. So that's it. So the first interquartile range here in our example was this number 1232 days. So 132, and the median here in our example was 281. Yeah, 281. 281. Sorry. And the third interquartile range was what it is. Yeah, here. 365 days. 365 days, and we need the sample size for these values, not the total number of the study or something. We took these median and the interquartile range, and this was the sample size for them, 688 people. So we will put it in the spreadsheet 688. This is the calculated mean and the standard deviation for them for the follow-up period. So these people, their mean was around 259.3 days, and their standard deviation was plus or minus 173.1, let's say. So it will basically take them copy and paste them into your data extraction sheet. So we do like this. So it is easy, it is simple. So actually that's it about the data conversion that you need to know actually for working on systematic review and meta-analysis. So there is another thing um, for the conversion, but you won't really that much. A tool called the EBM helper, and the EBM helper, as you can see, we can, if you are working on, especially if you are working on cross-sectional studies, cohorts, and the case controls, you can, if you are working on one of them, and you have a value in prevalence, for example, and you need to to convert them into a risk ratio, for example, you can, or odds ratio, you can just put it here. Here you put the, for example, the disease and the outcome here, for example, and here the disease without the outcome. Let's say let's say comparing in a cohort or a case control study the effect of yeah, let's say stroke and delirium, for example, or any psychotic syndrome and stroke. So here stroke and delirium, here stroke with no delirium, here no stroke with delirium, here no stroke, no delirium. So in the sample size, and we press calculate, and they will give me the odds ratio, the relative risk, and the risk difference if I want to, and so on. So this is another tool. There is other tool for the conversion of odds ratio and risk ratio, and it depends. For example, you want to convert odds ratio to risk ratio, then you have the odds ratio value from the paper, and also you either you know the event rate in the non-exposed, the control group, I mean, if the control group and the event rate, let's say here in my example, is delirium. So how the event rate of delirium in the non-exposed or the control group was known. So I put it in the I choose scenario 1, and if I do not know it, but I can estimate that the event rate is more than 10% of the sample size. I can choose scenario 2, and the opposite of the event rate of delirium was less than 10% of the sample size. I choose scenario 3. So if I click it, there are, as you can see, multiple things here. I put here if I don't know the non-exposed, but I know it is more than 10%. I put it here, we calculate it. If I don't know the event rate, but the event rate is less than 10%, they tell you that the relative risk or risk ratio is approximately equal to the odds ratio. And if you know the percent of or the event rate in the control group, you put it here, and they calculate for you the relative rate or the risk difference. And there is what's called number needed to treat and number needed to harm. This we can discuss later. It is more advanced, and it needs a whole lecture for it. Yeah. To make you understand not the need or not the number needed to treat or harm, but how we got to this point. It is a little bit complicated, but as the name implies, it calculates the number needed to treat and the number needed to harm. How number of patients you need, either to make the intervention that you have uh, treat make an effect, I mean, on people, and how number you need for this risk factor to really affect the people and harm them. This is actually what it really means. So yeah, these are the things you need to know about the data convergence and so on. Now I have let's say an example for data extraction. It might be not accurate because was not based on anything. I just came with the idea. It is not a real example, so it might be not that accurate. But you will learn the concept of data extraction um, from articles. Here I put the studies file, the three files here. Let's click them here. I will have our articles. What we are talking about here, the effects of dexamethasone, I think this is its name, and propofol, both of them are used for sedation, either to induce or maintain the sedation, and their effect on the outcome of the people undergoing cardiac surgery. So let us do it. Here it is. First article. This is the first article. Okay. And I want some information about it. What I want here is the continent and the country. Here, let us see. It is in Tennessee. Okay. So I'm not sure exactly where Tennessee. I think it is. Wait a minute. Wait. I think it is in the method they will say where is exactly, because it's called. I saw the word Edinburgh, Scotland, but it is not in Edinburgh. Wait, it is in Tennessee. I think they published it in the Royal College of Surgeon. Yeah, Ireland. So it is in Tennessee. So actually, I don't know where Tennessee is. It is in the United States, I suppose. But yeah, it is a U.S. state. So, yeah. So I will here write USA, North America. Okay. Why this is relevant? Because I can, if I have too many articles, I can use them. I make group analysis for the studies conducted in North America, for the subgroups analysis for the articles for the studies conducted in Asia, and so on, to see if there is any difference between them. And this is an RCT. So here's the sample size for both groups. How we do this? This is usually in the first table 1, in every the baseline characteristic. Here is the sample size 28. So 28 and 29. So they are similar in numbers. 28, 29. Okay. Then in the same, because this is the baseline characteristic table, usually it's called table 1, and data extraction sheet, it is usually called table 2. So we are extracting the baseline characteristic each one by looking at the first table. Usually, it is the first table in every study, the baseline characteristic of their sample groups and so on. So here we have the years in mean and standard deviation. So we don't need to uh, do anything about it. We just take it as it is. We won't convert it to anything, and then copy paste them. Should have uh, copy and paste the whole thing. So within the other group, so it is easy. It's literally no brainers at all. So for example, the gender here, the males number, and yeah. So we will take it as it is. The males will take the other one as it is. And actually, if you looked here, there is no data for female, but you have the data for male. So you will just make simple math. 28 minus 16, 12, I mean. So you'll put here 12, and it is 43% here. And the propofol, it was 29, so they are 5, 5, and this 5 contrast considered 17%. So yeah, 5, 17%. Yeah. Then if the article mentioned a baseline ejection fraction for them, most of the papers talking about cardiac surgery, they usually mention this in the baseline characteristics. If they did not report it, you will just put not reported, or type NR that it was not reported the uh, baseline characteristic for the ejection fraction, baseline ejection fraction. But I need to first make sure by reading the methods. So I will try to skim it to see if there is anything about um, uh, about this piece of information. Um, I think not. No, I think it was no. I think they did not mention at all the baseline ejection fraction at all. No, no, I think not. Yeah, yeah. Even in the results, I think they did not mention it at all. So I just want to make sure, because of course, if I'm working on this paper in real life, I wouldn't be skimming it. I would be reading it with full attention and so on. So yeah, there is there is no such thing. There is no any information about baseline characteristics. So you will put here NR, or it means not reported, or just write not reported, but just write the abbreviation. The abbreviation is enough. The population characteristic, you will copy and paste them from the article. Let me see here. The baseline. Yeah. Which is the inclusion and exclusion criteria for the patients in every RCT. Actually, patients deemed eligible for inclusion were randomly fall and so on were included in the study if they all met the criteria. This is what you mean. Age or higher sedation protocol. Patients we excluded were كذا كذا. Yeah, this is this is the characteristic that we want. We'll just put copy and paste them like this. Do like this and make it bigger, make it not messy like this. And sometimes when you copy and paste them, you will find it like this, not needs some modification from you. It is too messy. So yeah. Yeah, it is always good to make your spreadsheet is presentable to impress the your study lead, to make him know that you are, yeah, you know, you're a good data extractor, let's say, and I will take you in or I will contact you when I need you again in another systematic review or meta analysis. So here is the first article for the first table. You will need to do the same here for them. Let me just copy paste this. This, of course, the study idea is the name of the first author and the year that it was published. Here, the drug dosage and the most of these are in the results, actually, in the tables of the results, and the dosage and the outcomes that they measured, and the conclusion. The conclusion in the conclusion part, or the in the last part of the discussion. The outcomes in the methods. Usually in the methods, they said that they will assess this and this and that. These other things are from the results, the tables of the results. The drug dosage usually in the methods. So let us go to the article and let us see the methods here. I think I looked at it here. Yes. All included patients admitted to the ICU beds 1 through 10 received as part of the sedation, and those admitted beds 11 through received propofol. All others decision condition per unit. No, this is not it. There is yes, this one I think. There is fusion agent. It wasn't here. Where it is? 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 Actually, sometimes it can be not reported, but it's weird. Yeah, here. The dose. Here is the dose here. And the probable dose was here also. So here the here is the dose. in this unit, of course. So they are not the same. Interesting. They are not the same. As you can see هنا per minute and here it is per hour. So you should convert them, but because I am there is for sure tools for this on Google. You just say converting mean and standard deviation of this value to this value, and you sure you will find some tools on Google. But let us say they are of the same dose, the same unit. So because I'm busy and I have an appointment, so I need to be quick about this. So let's just copy and paste them and just it like this, and you get the point. This is the most important thing, that you get the point what I'm saying. So or I'm talking about. So take the other one as copy paste them. Then yeah, here. Then the sedation duration, if it is reported in the tables. Um, time and target sedation. Yes, time and target sedation. I think this is it. I think yes, yes. Wait, why it is reported in percent and plus or minus 8? I don't know. Wait, it must be written in the in here. Shows few insignificance for the primary outcome and duration of mechanical ventilation. There was no difference between groups. Uh, they here talk about the mechanical ventilation. Yeah. I don't I do not talk about the mechanical ventilation. I'm talking about the sedation. Secondary outcomes. Safety outcomes also showing a few differences. The dose will there is no difference risk between mm, incidence of high tension. The difference between growth using analgesics. Usually groups and comparing. I don't know about this. I don't know. Uh, so I don't know. Yeah, here I think. Yeah. However, patients in dexamethasone groups went a significantly greater percent of time. Sorry, oh, time and target. Weird. Weird. I think the time and because I have a few knowledge about this, so it might be weird to me to the term time and target sedation. If this is what happens to you in real cases, you should ask the study lead what is the time and target sedation and why they are presented in percentage. So yeah, okay. Let's just put it as it is. Uh, here, why we have the mean standard deviation and total in different slots? Because in the software of we do the meta-analysis upon they require the mean and the standard deviation and total mean and standard deviation and total. So it will be easier for you if you put it like this in the extraction sheets. So you could just make it like this and copy paste them into the software to make it easier for you. So And of course, if it is if it is a continuous outcome, if it is a dichotomous outcome, yes and no, happened or not happened, it is present in event and total, event and total. So let's put it here as it is, because really I don't know why they are putting it in percentage, not in hours or something. Where it is. Uh, yeah, here, time and target simulation. Yeah. Let's put it here. Put here 8. And the total here was in the from the base line table was 28. So let us put like this 28, 28. So here I'm the 29 here. Put it here. Sorry. Yeah. Okay. Here the mean for the other one was here like this. Copy paste me. Yeah. Paste 10. Okay. And here let us just equal to uh, this one. Yeah. And let us put here equal to this cell. No, this one. This one. Yeah, that's it. So to make it easier for you, the event of delirium here, I think I noted this. Yeah, here the event and total. It is presented either in the paper as event and total. Here the other one was 10. So 10. Yeah. Here the time to extubation. I don't think it was mentioned here. Um, no, it is not mentioned. I think no, it is not mentioned. So let us put it here as NR NR. Let us put here also NR NR here NR here NR not reported. The Brady incidents, it was here mentioned. I think yeah, one one yeah. One. So let us put it here. Here, where is it? Where is it? Here. One. Just put it. No, you know what? Mm, just put it manually. And here's 28. لا, no, the opposite, I think. The opposite. Yeah, the opposite. Yeah. You need to be so accurate about this because this is your study, so you need to be accurate about it. So here one, here two. Where is it? Two, two Brady. The hypotension was, let us put here the 28, 29. Let's make sure it was 28, 29. Yeah, 28, 29. So the event for hypertension was 17 and 13. 17 and 13. Okay. 17, 13. Okay. The outcomes here, the outcomes, you need to take it from the methods here. The outcomes they wanted to assess. The primary output was the duration of the, and the secondary was here are they? Yeah, here are they. Yeah, this is the outcomes, and you'll just copy paste them here and do like this. Wait, what happened? Yeah, let me drag this here. Let us rearrange this. Okay, and we will do like this, make it presentable. Yeah, first is the outcomes, then the conclusion. The conclusion in the conclusion part of the paper. Yeah, and you will just copy paste the conclusion. Really, that's it. Um, Let me put it here. No, I don't know why this happens here. And okay, let's say here it is, and that's it. The the other, the other parts of it. Let's put it like this, yeah, just to make it easier for you to see. This is how you extract the information. That's it. This is our session for today. I hope you covered all of it. So yeah, that's it actually. Yeah, have a nice day.